Hi everyone, thanks for joining. My name is Andrew and I'm here with other members of the Go team. And for those of you who don't know, the Go programming language is an open source language that's been developed by a team at Google and more than 200 contributors from the open source community. It was released in November 2009 and in March this year we released version 1.0, which is a version that will be supported for years to come. And I'll just get everyone to introduce themselves, starting from the left, and a bit about what they do.
I'm Brad Fitzpatrick. I work on the standard library and libraries within Google and miscellaneous bugs and whatever.
Hi, I'm Ken Thompson, and I'm semi-retired. I worked on Go until the public release in November and a little after that, and now I'm having fun.
I'm Rob Pike. I work mostly on the libraries and help with documentation and basically make trouble.
I'm Robert Griesemer. I wrote part of GoDoc and GoFumped and worked a little bit on the spec.
He wrote the spec.
I'm David Simons. I've worked on the Go runtime for App Engine and a bunch of other things in the standard library and inside Google.
And I'm Andrew Durand, and I am a developer advocate. I'm the sort of public interface to the Go team at Google. And so without further ado, I'll just invite people to come up to the mics. And Nigel, my glamorous assistant, is also a member of the Go team, and he's going to read some of the questions from the Dory. Oh yeah, and I should mention that other important members of our team, like Russ Cox and Ian Lance Taylor, who couldn't be here today, just do really great stuff, and I wish they were here with us.
Let's do a couple of questions from the moderator page, but also the recurring questions. So the first one is, what is the core Go team spending most of its time on? Start again. What is the core Go team spending most of its time on since the Go 1 release? What sort of things can we expect in the medium term, say 6 months?
Mostly, the Go 1 release formed a boundary for a stable language that we knew we could sort of depend on. And so now we're focusing more than we were before, although certainly not exclusively, on more internal development, trying to get some Go development inside Google, because we made the language to help make Google more productive and helpful internally. So there's been a shift of focus. I wouldn't say it's a majority time, but a lot of us are working more exclusively on internal stuff. The longer term, there's a bunch of stuff coming. We'll probably do a Go 1.1 release, maybe sort of end of year-ish. Do you want to talk about that?
Late, by the end of the year, we would say.
Yeah. And that'll include a bunch of performance improvements. We've got some pretty amazing compiler changes that have given remarkable speed-ups to some programs. The libraries probably won't change all that much for Go 1.1. You might add a couple of minor things. The thing is that once you commit to a library, you've got to be sure it's right, and we really, really care about getting the APIs right. So I suspect there won't be a lot of API change until we're absolutely convinced that that's the right model. That's sort of a bigger thing than a point release. There's some garbage collector changes that will make it significantly more efficient on parallel execution, and a precise collector is in the works that will make 32-bit collection much more effective, and therefore eliminate that sort of one sort of sore spot.
We're also hoping to promote some of the other operating system ports, like the OpenBSD, NetBSD ports, and then there may be another one, to that fully supported status. Currently there's only FreeBSD, Windows, Linux, and Darwin. And so they should be in 1.1 as well, depending on the state of them. Oh, and there may be some scheduler changes as well, but we're not sure how they're going. But the long and short of it is that 1.1 is really about tightening the screws and making things faster and more efficient and more reliable. We're not looking at any language changes at all until Go version 2, and we're not sure when that will be. So we don't have like a long-term roadmap for the project at the moment. We're really happy to be in the position where we have something really that we think is really great and really solid, and a great platform for which you guys can use to build reliable software.
You can get up and ask questions as well. Let's take another one from Nige.
I know it's been asked before and probably again recently, but do you have any news or plans about Go on Android?
No.
Clap.
What feature or design decision of Go had the most surprising impact or changed the way code was written the most? Defer, interfaces, reflection?
In just volume of code, I think it's slices. I think they turned out to be very nice.
Ken designed the slices, by the way. I should mention that Robert and Ken and I, who were the original sort of instigators of all this, spent, it was probably a year trying to figure out how arrays would work, because we knew we wanted some sort of variable-sized array, but we also knew we wanted fixed-size arrays that were statically checked, and we had these things called open arrays. I don't remember how they worked, but it was a real struggle. We spent a long time, and then Ken walked in one day with the slice idea, and it wasn't clear it was the right answer, but as soon as we started using it, it was obvious. So, yeah, I would add, I think that there's sort of two parts to that question. One is what made existing Go programs change, and I think slices are definitely the answer there. As far as how I think about programming is different. For a lot of people, it's the concurrency stuff, but I've been using concurrency longer than some of you, and so it wasn't as big a deal, although I love having it. For me, the whole idea of interfaces profoundly changed how I think about software development. The idea that a program is composed of these things that stick together feels so sort of easy to work with. It just changes the way software gets constructed. It changes the way libraries get built. And for the sort of day-to-day programming I do, I think they're the biggest single thing. Anybody else?
Yeah, maybe the fact that a package file is can just be a single file as opposed to two files where one is specifying what you export, as is still the case for the standard systems programming languages. I think that reduces your number of files just there by a factor of 2, and also makes it much easier to maintain your code.
I also remember that when we changed it so that all of the globals in your package could be declared in whatever order you wanted, you didn't have to pre-declare. Ken came in one day and he said, "This is the best decision we ever made."
Yeah, I would go further and say that the entire way packages are arranged is where you can have packages that consist of multiple files, and it's all kind of fairly loose, has really made the process of building software from the ground up much more straightforward and fluid. And I feel like refactoring and everything becomes really a very minor deal, whereas it can be very difficult in other languages. Hey, Bob.
Hey, Andrew. You talked about improving the scheduling of Go routines. I'm wondering if you can discuss it, what type of internal discussions you have of how to improve that type of schedule without writing an operating system on top of an operating system.
Well, it's actually been an external discussion on the Golang dev mailing list. One of our prolific contributors, Dmitry Vyukov, who we should thank profusely for his great work on improving the efficiency of the runtime and other. Anyway, he actually posted a proposal for a revised scheduler, and that's what's been under discussion. So there's kind of tentative plans there, but I won't go into it now. But it's if you're curious, it's all there online.
Thanks.
I would like to just add that you kind of do have to implement an operating system above an operating system. That's really what the runtime is. And what it's doing is it's changing the primitives you have that the operating system doesn't give you. The main thing that Dimitri's doing is trying to speed it up by structuring it differently and thinking about scheduling things in a different way, and I think it's a big deal. The thing he's not doing, which I think needs to be done at some point, but it's very, very difficult to do well, is some kind of, preemptive scheduler. The current scheduler will schedule a particular thread, or therefore Go routine, only at communication points, locks, system calls, things like that. So if you have an infinite loop, it'll never yield the processor. If you're running on multiple processors, if your program is truly parallel, then you can get them to execute independently, but the load balancing doesn't work right unless there's some sort of preemption. So I think preemption has to happen. It's a very difficult subject, and we haven't done it yet because we've been worrying about other things. And it doesn't have a huge effect on things like correctness, but it does mean you can do a much better job of managing resources, but we don't have it yet.
So I know this was covered a little bit in the previous session, the concurrency and synchronization features of Go channels. But it seems to me that it supports really one paradigm or one pattern of concurrency, which is really the producer-consumer framework. And I guess if you can also add semaphores if you look at the buffer or queue length as a synchronization feature. I'm just wondering if anyone has done a survey of a number of design patterns in concurrency, such as the ones in java.lang.concurrent or some other large library where there are a lot of different design patterns for concurrency, to see if any of those should be implemented as higher order features on top of the mutexes and semaphores that are provided in Go libraries. So basically, the short form of the question is it true that really we're just looking at producer-consumer relationships with Go channels? And the next question then is, should there be some higher order features built on top of the semaphores and mutexes that are the low-level synchronization features that are provided in the libraries?
Well, there's some things already there. There's like sync wait group, which is like, countdown latch in Java or whatever. And it's also pretty easy to build your own primitives on top of those. We have a library that I use on a lot of my servers called single flight, where if you have like say a web server and 3 people kind of come in roughly at the same time and they all want something expensive, I have just a little function that latches on to existing requests that are in flight and then multiplexes the answer out to everyone. And it's a tiny amount of code, but that's a primitive you could build using existing Go routines and channels and stuff. So there could probably be a package like syncUtil that puts about a lot of these patterns into a library, but outside of like wait group, there's not too many of them right now.
I think also part of the issue is that these kinds of, because these primitives are so easy to write, we've sort of shied away from including too many of these tricks in the standard library because everybody's need is subtly different. And if you just write the code yourself, you have total control over the intricacies of the particular piece.
Although most people shouldn't be writing that code, right? Most people shouldn't be writing sort of low-level synchronization primitives if they want their code to be safe. I don't trust most programmers to write this sort of code.
I actually take objection to that. I think in the last talk I showed a lot of really interesting examples that didn't have low-level synchronization of any kind. And part of the whole point of the design of Go's concurrency is that it's not low-level. And I don't object to having low-level synchronization primitives where they're necessary, but Go takes a pretty firm stand that you can think about large-scale concurrent programming with much higher level, easier to reason about primitives. And I think you're being a little contentious on how you're describing that. I'd also like to say that saying that the channels promote a producer-consumer model is okay, but you can do other things with it too. I mean, the whole idea of a channel on a channel doesn't map into the idea of a producer-consumer kind of thing. And there are really rich models that you can build with these that don't have the flavors of these words you're using. That said, I completely agree it would be fantastic to have libraries for some of these larger level things, but I would make the libraries not be things like semaphores, but things like multiplexers and load balancers and that kind of thing. A much higher level rather than sort of just one level up from the locks and things like that.
Right, thank you.
I'll just add to that it's also sometimes a trap that new Go programmers fall into where they try to map concepts from other languages too directly when they start to write Go. So it could be very easy if you're familiar with, say, writing concurrent code in Java to come over to Go and immediately look for all the things from Java util concurrent in Go to pretty much write exactly the same code just with Go syntax. Part of the appeal of Go is that you can structure your program in a very different way, something that could be a lot more natural or decomposed into Go routines because Go routines are so efficient. The more mappings that you provide, the easier it is for people to not take a step back and rethink how they've structured their code.
In broad strokes, can you tell us a bit about the problems that led you to create Go in the first place, and then how your goals have changed for Go as it's got more real-world adoption and gotten out there? Are they still the same, or has it evolved a lot?
I actually gave a talk just last week on...
Do you have it here? You could just...
give the talk, yeah. I mean, it's kind of a cartoon answer, but it's fairly accurate that we we're doing a lot of C++ development, and I mean, the joke, but there's a grain of truth in it, is we got tired of waiting for the compilations. We were building these massive binaries on massive compute clusters, and it was taking order an hour to build a binary. And we thought, why is this the case when a video game can generate 100 frames a second using, what's wrong with our world? And we thought about the kind of software that we build, which is basically web servers and backends, and that's one branch. But then we also thought about why these things take so long. And it's mostly because of the dependency hierarchy. And in C++, to a much greater extent than Java, say, the dependency hierarchy is very uncontrolled, right? You include a header file, but you don't know whether you need it or not unless you take it out and find it doesn't compile anymore. And with all the if-def guards and nonsense like that, it's possible to have complete uncontrolled dependency stuff, which causes things to be built many, many times. Mike Burrows, who built the Chubby server, was waiting for a build one day. We spent a lot of time waiting for C++ builds. And he noticed a file went by that he didn't understand the need for in his binary. And so he looked into it, and it was a file he'd never heard of in a package that had no business being linked in, and the header file was being compiled 37,000 times to build his binary. And you laugh, but that's what happens when the model is you use if-def guards to protect your dependencies, and you just include everything and let it build, and it becomes this incredibly dense nest of too much work. So a key driver behind Go was making that not possible, fixing through the language the dependency problem, having totally clear dependencies, rejecting unused imports, making the dependency problem solved by the compiler. And there's a key point there, which we've talked about in talks before, which is if you have a package A that depends on a package B that depends on a package C, but A does not itself depend on C directly, right? So A depends on B and B depends on C. To compile A, you should not have to compile C along with B. So once you compile B, it pulls up all of the information about C that it needs into its object code. So that when A runs, it says import B, all it has to read is B. And for 3 steps, that's obviously a trivial thing. But when you have thousands and thousands of files, that can save exponentially in the number of dependencies you have to look at. And I mean exponentially. And so Go builds take a fraction of a second, partly because the compiler is fairly quick, but mostly because the dependency problem just doesn't exist in the language. And that was a really, really key part of it.
And is that still what you see as the most important problem today that Go solves?
For me, the reason I was enthusiastic about Go is because just about the same time that we were starting on Go, I read or tried to read the C++ 0x proposed standard, and that was the convincer for me.
The thing I like about it is you can actually find the code. I read C++ code, even code I used to write that I wrote, and I just try to trace through it, and it's bouncing around dozens of files, dozens of callbacks, and I like being able to read code that reads top down. I've been porting a lot of C++ code at Google to Go, and it gets substantially shorter and readable, and we can see the logic finally, whereas it used to be spread over so many files that you couldn't actually get the high-level picture of what your server was doing.
And as somebody coming from a different angle who I don't have a C++ background at all, but I worked mostly in more dynamic languages like JavaScript and Python. And what I love about Go is that I can write the sort of software that I want to write with high performance, which is not really verbose code. It's very simple to understand, and the code that I read on the page is the code that is executed. Like when I iterate over a slice, there's not some chance that there's like an iterator implementation that fetches a file from a web server in Romania and serves me some JSON or something. Instead, the language is very deliberately sort of simple and contained, so that it's very easy to reason about code that you're reading. And as programmers, we tend to spend way more time reading other people's code than writing code. And I think that speaks to what Brad is saying, is that if you dive into a Go project or like the Go standard libraries, it's very, very accessible, and more accessible than any other language that I've worked in.
It's also nice to be able to block for a change. When you come from writing servers where it's all callbacks on callbacks on callbacks, like Node.js code or whatever, where every line of your code is indented a little bit more, and another anonymous function, it's nice to be able to be like, oh, I can right to the network there, and I can wait however long it takes, however slow that client is, and then I go to the next line of code. I don't have to name that. I don't have to name that Lambda. I don't have to name that callback. I just write code.
I have written a lot of C++ code in my previous life, and I think you can actually write quite nice code in C++, but you have to be incredibly disciplined. And almost every company that I know, they have an internal style where they, just use a subset of C++, because otherwise they just can't control their code. And so even if you're very disciplined and you make an error, it's incredibly difficult to find them. Now, in Go, why wouldn't it would be really nice, I thought, if we had a language where these things are simply not possible. And the fact is that all or many of the ideas that we have now in Go actually existed for a very long time ago. Rob Pike pointed out many of the concurrency ideas, they were invented 20 years ago, 30 years ago. The whole...
The 50s?
The ideas about how you organize packages, they go back all the way to Ada and Modula 2. There's a lot of ideas in Go that have been around forever in different languages, which all, for some reason or not really made it to a mainstream. And I thought it would be nice if we had them. I want them.
Is anyone doing
one more point before you go? Sorry, is this on? Robert mentioned this thing that everybody subsets C++ so that they write in their own subset in their company. And last week, Russ Cox, who's not here, joked that maybe the C++ style guide has all that in it, but the Go style guide should start by saying you can use the whole language.
Is anyone writing a kernel in Go? I've always wanted to have this idea where I could just push services out of the kernel into userland like a microkernel and then rewrite them in Go one at a time and then keep going until the whole thing was Go.
I believe Ross actually prototyped a completely standalone sort of mini kernel that was just written in Go and ran on bare hardware.
And somebody else ported something like BusyBox that ran as a init. And so the whole userland at least was Go, including the shell and all the tools. So, as at least as a proof of concept.
Thanks. Another question, just Amazon Web Services, any experience, tips, tools?
Relating to Go and Amazon Web
Yeah,
Services?
sorry, obviously.
Well, use Gustavo's Go AMZ package for talking to Amazon. It works. Or not, as may be the case.
I don't do anything fancy on Amazon, but I run a lot of Go code on Amazon, just on random single machines, and it runs fine like anything else.
Yeah, we support x86 hardware.
So it has been said that inside C++, there's a very small and beautiful language that's trying hard to get out, and it appears that finally it is getting out. So my question is, how would you compare Go effort to effort by Digital Mars and Andrei Alexandrescu with D?
That's, I don't know what I should say here. I attended a D talk a couple of months ago, and one of the questions that was asked about D is, what happens if a new paradigm comes along? Is D going to, incorporate it? And the answer was yes. And I think, I cannot speak for the D developers and inventors, of course, but my impression from this presentation was that D is going to grow very, very much the same as C++ has grown. And I think in Go, we're trying to do a completely different approach. We're trying to take things out as much as we can to reduce them to the bare bones, to the absolute minimum that you need to build everything up. And if those little pieces are orthogonal and work well together, you actually get something that is more powerful than when you have like a lot of features that kind of all scratch each other a little bit and then have very weird side effects that are difficult to understand.
Thank you. Maybe you guys can speak briefly about the design process of the language as well, if you want to.
It was interesting. I did some, for this talk last week, I did some archaeology, and I found a mail message from the first week, actually a thread, with the three of us talking about it. And it was remarkable to me how much of the flavor of the language emerged in those first conversations. We knew what we wanted and fairly quickly converged on a rough approach to what was going on. I think one of the most important things about Go in its design is that Robert comes from a very sort of object-oriented, small talk, Operon kind of background. Ken is, did Unix and worked on C stuff and things like that. And I have this concurrent sort of point of view about everything. And so we have three completely different worldviews. And to design a language with three completely different worldviews, one thing you do is you just put all the ideas in and woo, and you get something, right? But instead, what we did was make sure that every single feature that went into the language went in only when the three of us agreed that it was the right feature and the right design for that feature. And I think that's a really important part of why Go works so well, despite being a fairly simple language, at least in broad strokes. Do you agree with that?
Yeah, I would agree with that. I want to say one thing. I think it was incredibly hard process. I think there were, I don't know, several times where I probably yelled at Ken Thompson, and then I would, go back in my room and said, "Hey, you don't yell at Ken Thompson."
Did you yell back?
No. I remember one instant, and basically it was almost the first day when we wrote a big list of things on the blackboard, and there was one question that we spent maybe 10 seconds on. Should the declarations be C-like, like inside out, or should they be Pascal-like, left to right? And we said Pascal-like, and that was it. And then from then on, declarations were in.
Best decision ever.
But one that early on got a lot of flack. I think it was definitely the right decision. Thank you.
The next question from the moderator, what has the biggest mistake in Go's design turned out to be, and how have you worked around it? Is there a billion-dollar mistake in Go?
Well, so the billion-dollar mistake, I guess, refers to null pointers, and yes, Go has null pointers, so we have the billion-dollar mistake in Go.
And some people don't like it because of that. I don't think it's a billion-dollar mistake, but what do I know? Mistakes. I wish that some of the syntax, it was a little simpler in a few places. I think there are too many ways to declare a variable, and there's this whole shadowing nonsense and so on and so on. But I don't think there's a huge single thing that I feel is wrong. Part of the Go 1 process was actually going through all of the things that were bugging us and fixing them. And so a year ago, the language looked quite different from what it does today, but we fixed a lot of it, and a lot of stuff got cleaned up. And that's precisely what the Go 1 release process was all about. So we fixed the things that were bugging us, but for biggest mistake in the language, I don't know. I don't have a good number.
There's the scoping of loop variables. That's kind of confusing to a lot of people.
For loop variables, that confuses people. I don't think, I think it's fine, but you can see why a different decision would also be fine. So, but this is the kind of thing you can't just change, right? Once you've decided people are using your language, you can't change the semantics of a for loop. That's kind of scary.
Yeah, I mean, that's the one that I regret, but the reason why we decided not to change it is that it would have been incredibly subtle to detect when people were using it.
So what led to your design decision to, in the formatting of Go code, the canonical formatting, to use tabs instead of spaces?
Good taste.
I'll go. If you read the ASCII spec, it says a tab is some number of spaces set at tab stops. And so it just appears that that's the definition of what you want there, that instead of saying 5 tabs or 8 tabs or 2 tabs, spaces, excuse me, the answer is a tab. It's the definition.
Make your editor render it how you want it to look.
So I wrote GoFump, and the reason for writing it was, unrelated to this. It was just that we wanted to get rid of some silly discussions about how you format code that just consume time. But then when it comes to indentation, I thought, everybody has a different style. And ideally, it would be great if everybody could just look at the code the way they want to look at it in their editor. And with indentation, it's a very contentious thing. Some people really want a lot of indentation. Some are happy with, two spaces or even one space. And the fact of the matter is you get used to everything. But with tabs, you at least have the chance to actually change it in most environments to be of a different size. And the idea was that by doing that, you have a chance to actually adjust it to your personal needs. Now, it turns out I think that's probably not true in reality. People don't really change that.
That's not true. I know Ken uses 8-space tabs, and I use 4-space tabs.
Okay, there you go.
Even in the Go team, everyone I think uses a different editor, and everyone has different preferences on syntax highlighting or fixed width fonts versus variable width fonts. So, it's not like we're very religious one way or another. We just use what we want to use.
The most important thing about GoFumped is not the choices it makes, but that it makes them. The fact that there's a program that formats the code, I actually would publicly like to thank Robert, because I think he did an amazing job on GoFumped. It is an incredible tool, but it also enables things that we didn't realize up front. Once you can take up because what GoFumped does is it reads your entire program, parses it into a full Go syntax tree, and then reformats it, or maybe just leaves it alone, but it depends. But because of that ability to pick up a syntax tree of a Go program and generate human-readable, commented, neatly laid out code, we can write tools that do things to your Go program that would be very difficult to do automatically, like the GoFix tool that'll go in and rewrite your program to bring it up to date to go on spec. That would be almost inconceivable if we didn't have an automatic code formatter. And it's such a powerful idea that we're starting to think about doing it for some of the other things. You can imagine a makefile version of GoFix that would let you edit your makefiles automatically, or conceivably other languages. Java would probably benefit from that kind of thing. Being able to rewrite your program and generate human-readable output wasn't the goal of GoFumped, but it turned out to be one of the most important properties about it. And if you get tabs instead of spaces, I think that's a small price to pay.
Thanks.
For me, GoFumped, before GoFumped, there was continual wars about whether curly braces were at the end or at the beginning, or all sorts of things. And while I don't, at the time that GoFumped was written, I didn't agree on all the decisions. But now there's no wars, there's no arguments. It's just the way it is, and that probably saves half of the discussions that go on at Google over C and C++.
The next question is about what's happening with garbage collection over the next 6 months or so, but I think we covered that earlier with the roadmap. So the next question after that, are there any plans to distribute Golang threads to work across similar machines to create truly distributed systems? If something like this should be implemented for Golang, what do you see as the challenges that should be considered?
That's something I really love to see. I think there's two ways to do it. The way the question was phrased was to distribute the threads. That sort of implies some kind of process migration aspect, which is not the way that I would approach it. A long time ago, I wrote a little toy package called netchan, which lets you turn a channel into a network connection so that you can have two machines sharing a network, but using the channel primitives on either ends to manage their communication. And I think that's a really good idea, but I didn't get the API right, and so we pulled it out of Go 1. And we've been talking again about what the design for that really should be. And I think it's a really, really powerful idea. But one of the things we want to make sure happens when you do that is that all of those patterns I showed you in the previous talk still work. So you should be able to send a channel over a netchan and stuff like that. And getting that done is actually quite subtle and difficult, but we definitely want to see it. I can't promise any date for it because it is a hard problem, but it's definitely from the beginning an idea that we had. I remember Ken and I had a conversation sometime in the first year. We probably had like 5 conversations about how we were going to get channels and networks together. And we never quite figured it out, but we still really want to see it happen. I should mention Erlang, by the way, gets this done, but it has a very different model.
So I love Go concurrency, but I know some problems are better solved using GPU parallelism, and I wonder if anyone's using GPU parallelism in Go.
Not that we know of.
Only in the same way that they use them from C or other languages. There's no, it's a sweet idea, the idea of launching a Go routine that runs on another on a auxiliary processor in some heterogeneous system, but it's not something that exists now, and it's certainly a difficult problem.
So my understanding is also that all these systems which employ that parallelism use specialized languages for those GPUs, because the GPUs pretty much change from year to year or even half year to half year. So if I'm not an expert, but I suspect that if you use it, let's say from C, that you're just invoking or sending those snippets of that other language. Yeah, okay.
My understanding is there's actually a compiler that runs on the video card, and we haven't yet managed to port Go to a video card, but it would be cool if we could.
If Russ has a free weekend, maybe.
The next moderator question is about Go 1.1 on the roadmap. I think we covered that already. The next one, any plans to port Go to MIPS? A lot of embedded hardware with network support runs MIPS, and writing network software in Go is so much easier than in C, C++.
GCC Go should be able to output code that runs on MIPS.
It's already done.
Yeah, so we'd love to have more users. So anybody who's hearing this and has the hardware? Oh yeah, okay. So for those of you who don't know, we have two compilers that the Go team work on actively, and there's the GC, which is the one that was based on Ken's Plan 9 C compiler design, and that's the one that you get with the standard Go distribution. And then in GCC 4.7.1, GCC Go will be included, which is a front end for the new compiler collection. And so you can compile Go code for all of the platforms that GCC can target within some constraints, I believe. We're publishing a blog post about this within the next week. But with GCC Go, you can, I know people have run stuff on Spark systems and MIPS Alpha, IRIX, which is Alpha, yeah. Other operating systems we don't support, and so there's a lot of scope there. But it's not that it's not supported, it's that it's not been well tested. So if you have these kinds of systems, we'd love for you to get GCC Go and try it out, and let us know how it goes.
And both the compiler suites were written to the spec, so as far as we know, they implement the same language. Of course, there's probably bugs and variations, but as far as we know, you have no problem compiling programs on either suite and have it work.
So is there a plan to add versioning to imports or external packages?
No, not at this stage.
Because it's kind of hard if an external package or some library that you're using changes API, and you want to use go get to get that library, and it's in a different version, you have to jump in and git check out another.
Yeah, I understand the problem, and I'm sure other Go developers do as well. What we're trying to encourage Go package authors to do is maintain a consistent interface. And if you're going to change the interface, it's probably wise to change the import path as well, and have like a V2 of your library that supports a different kind of interface. And that's just part of release engineering, and I think it's something that some parts of the open source community do well, and other parts that are more ad hoc don't really address very well. Brad has more experience with this than me and some very strong.
I was just going to point out, you shouldn't rely on that though. I mean, the responsible thing to deploy code to prod is not to have a script that runs go get, and which could be malicious code. Maybe that GitHub author's account got taken over or something. So use go get during development, and then once you're going to ship something, put it in your own version control system, snapshot it, whatever.
Also, you don't have to update all of your dependencies every time. The default behavior of go get is only to fetch, not to update. So get it to a working state, and then don't only -u with go get with care.
Are there already any backwards incompatible changes being thought of for the fabled Go2 release?
No, but that's not to say there won't be. We just haven't thought about it. Really, Go2 is in the indefinite future. It's years away. There's been a couple of ideas that have been mentioned that might be Go2 things, but we're not thinking about Go2. We're just not. We're thinking about taking what we built so far and using it, because the ideas in Go2 will be ideas that we develop using Go1 and finding out what we need to make better.
But I think to answer the question literally, I think by necessity Go 2 would include backwards incompatible changes. Otherwise it would just be Go 1 point something.
Are there any plans to bring a self-hosted compiler to Go?
I mean, we're not doing it, but other people have discussed it. There's a project called LLGo, which is a Go compiler that uses the Go AST and Go parser and all that. And then they're fleshing out the type checking, and then they're emitting LLVM bitcode and whatnot.
What's the reason behind that decision?
Some guy's having fun with it.
No, I mean, what's the reason behind you guys sticking with writing everything in C instead of moving to self-hosted?
I mean, the pragmatic answer is there was no Go to write Go in initially, right? Yeah. I mean, look at Rust. They took a long time writing their compiler in Rust because Rust didn't exist. So, I mean, it's a route, but it's just it's a very slow, painful route.
Okay. Thank you.
It's much easier to bootstrap both locally and to other people if the compiler is written in a language that everybody has.
As Russ made a really good point in a recent Q&A session that he did, is that if you're changing a language, or if you find a bug in your language and your compiler is written in that language, it can be a very, very difficult process to correct the bug in your language and in the compiler at the same time. You have to sort of bootstrap the change and propagate it through the chain. And there are people on this stage who know way more about that than I do. But yeah, it's very hard.
But also, there is actually a significant part of the front end in the library. And as we speak, some people in the community are thinking about completing that part. So there would actually be a front end, at least for a compiler, where somebody could hook up a back end if they wanted to.
It would be a fine, I mean, Go is a fine language to write compilers. It's just we haven't taken it on yet. And I think maturity will probably lead to one at some point, but we have no plans at the moment. We're working on using it rather than rewriting the compiler.
Are there any plans to add anything like DL open or DYSim to Go for dynamically loading code at runtime?
No.
There are no plans. I will admit that although Go is statically linked, and in the first session today, everyone on the panel, I think, said how important that was to their deployment. So that having a static link binary is a really important part of what makes Go nice to use and deploy. I do think there's a real merit in having a dynamic loadable module, which is a slightly different point. And I actually kind of would like to see that happen. I don't think it's terribly difficult, but there are no plans to do so. I do understand the distinction, and it might be cool. Does what work with GC Go?
Using DL open?
I haven't tried it. I don't know.
It might work.
How large is the largest known Go project and the longest one running in production?
Yeah, YouTube's Vitesse project, which has a program called VTalk, I think is in the realm of approaching 100K. That sounds a bit high, maybe, above 50. It's hard to say because like the guys that we had on the stage today, I don't know how big their code bases are, probably sizable, but just on the weekend I met somebody from a fairly large company who said, when he met me and learned what I did, he said, "Oh, thank you so much for Go. We use it everywhere in our company." And so I had no idea they were using it, they didn't tell anybody. And so I think there are a lot of people that use Go that, they don't go out and just send us an email about it. Hey, I'm using your product. There's a lot of stuff that exists that is not out there. But certainly we're using it inside Google. Unfortunately, we can't go into great detail about that.
You should also remember that the 50K Go program is really a 100K C program.
Godoc is also quite big, and it runs in production, and it's been running for quite a while, several years now. The YouTube project's been running in production for at least a year or more, long before they open sourced it. So there's serious examples of large programs running for a long time in production, but I don't know what the specifics are.
I'd be very surprised if this hasn't been asked before, but given that Ken is famous for a paper, Reflections on Trusting Trust, where you can build a compiler that builds a backdoor into itself each time you compile it with itself, how do we know that we can trust Go?
Well, if you read the paper, you can't. Somebody said, I think in a Turing lecture, not me, that the popularity of a language is guaranteed when you get your first virus in that language. And I've heard that the first virus in Go has come around.
We're on the world stage now.
Are there any plans or desires to revive some of the old abandoned Go ports, TinyGo, native client, which were proofs of concept and which were really meant to be fully developed?
I was going to say Tiny was really an experiment, and I don't think Russ ever intended to take that further as something bigger. The native client port of Go was something that we were serious about at the time, but the native client platform has kind of changed direction a bit, and now they are focusing on people exporting bytecode. It's called PNACL, and it uses an LLVM backend to dynamically generate machine code on various platforms. And so that would necessitate a way of producing Go code that's in LLVM's intermediate language. And that's something that we would love to do and we'd love to see happen, but it's not something that we're actively working on now.
How much do I need to pay to keep generics out of the language?
How much have you got?
Next question. How close does GCC go to running in front of non-GCC backends like Clang?
I don't know if anyone's actually actively doing it. Certainly, one of the most remarkable achievements about GCC Go is that it's released as part of the GCC package, but it's not under a GPL. And the reason for that is that Ian really wants to see someone build an LLVM backend, or at least he wants the freedom for someone to be able to do that. And we're just waiting for someone who wants Go or thinks of it as a challenge to make it work. As far as I know, nothing active is underway, but it would be whatever amount of work that is and should be fairly straightforward unless I don't misunderstand something.
Any plans to create an official third-party software repository like Python, Pipel, Perl, CPAN, Ruby Gems?
Absolutely. So there's a fantastic site at the moment called Go Package Doc that was developed by a guy named Gary Bird. And it's a system that allows you to view the documentation of any Go package that's publicly accessible in a web browser. And it's a real asset to the community. And we've been talking about taking this further and turning it into a package index and a search engine. And we've got some really exciting plans. It's just a matter of doing it now. But I think the one notable difference between the approach we're looking at and the approach of things like CPAN or some of the other repositories is that it's not going to be human curated, but rather machine curated. And we feel like that might yield some advantages in some ways.
The other important difference is that Go's namespace is DNS. You use a URL to describe your package. So it's not like Perl CPAN where you upload it and you have some central group of people that say you're allowed to use that name. So we don't have a central naming authority, which is kind of implicit with a central model. So, you can be github.com/whatever or code.google.com or whatever, and that's your import path.
And that was a very deliberate decision for just this reason. We think we'd like to make it be automated, and it's an ongoing challenge to figure out how best to do that, but it's really what we want to see.
Are there any plans on adding the ability to call Go from C? In order for me to really use it as a systems language, I need to be able to bind to it from another language. Most languages have the ability to call a C interface.
Call one direction.
Yeah, you can't embed Go in C currently. Go needs to be main to set things up, but it keeps coming up, and people inside Google want it too. So I think Ian has said he wants to make it work, and Russ has said he wants to make it work. So it's definitely on some roadmap. I don't know.
The issue here, for those who don't know, is that there's a thing called CGo, which lets you call a C program from Go, and that works reasonably well. A lot of people use it for various things, and some critical parts of the library use it to do things like DNS lookups and stuff. The problem is that the Go runtime owns memory, owns the stack, and there's a calling convention issue across that boundary, which means that at the moment, you can only use it to go one way. So Go has to be running main. The change that's, the piece that's missing, but is going to come, although don't know when, is that C programs should be able to be the main program and call it Go library. That's the piece that's missing.
To be clear, you can still call from Go into C. You just have to start in Go. You can go to C, back to Go, and that works fine. So you can make a tiny, tiny Go program that embeds your C code as like the first line, the first and only line of your Go program. That works. It's just kind of a hack.
Yeah, and also if C++ is the language you want, there's the SWIG interface. Go is fully supported by SWIG, but the same kind of constraints apply there because it uses C Go under the covers, I believe, although I'm not sure.
There is some work in the community towards this goal. I know that there's a Python function call interface so that you can call into Go code from Python, and it's in the kind of the early stages of its development, but it works. So, you know, there's some momentum.
And you can also call Perl from Go, right, Brad?
Is there any interest amongst the Go team in writing a new operating system?
No.
Are there serious plans to support static linking of libraries pulled in by CGO?
It just doesn't work right now, but people want it. It's just work, I guess. Not by me.
Which is your favorite misfeature in Go? By that, I mean, which feature from other languages are you most happy Go is missing? Inheritance? Exceptions?
I think I am happy that there's a lot of the OO stuff not present that is in other languages, because it allows you to think about, you know, your task at hand as opposed to the hierarchy or type system, which you then have to sort of, you know, shape into whatever you want to do.
I like the lack of uninitialized variables. It's pretty good.
It's not exactly the same. Yeah, I'd like to echo what Robert said and point out that if you have a program in Java or C++, you pretty much start by designing your type hierarchy. And that's something you don't even do in Go, so that's one point. But a sort of deeper point is that it's a fair bit of work to do that, and there's a lot of structure you have to build in order to use the types in that hierarchy. And that means that if you find out after a few days' work that the hierarchy is not quite the way you wanted it, going back and changing it might not be an option because it's too much work. So Go, by not having that type hierarchy, makes it much easier to adapt the program as it develops, because that structure just isn't there to force a certain style on the rest of the program. Do you agree with that?
I think this is exactly what happens when you write a large piece of software. In the beginning, you think you know your structure, you sort of design it. It's not quite right. For the first couple of weeks, you're going to tweak it, and you're going to be a good citizen and, you know, refactor and organize. And at some point, you hit, you know, 20,000 K lines of code or whatever. And at that point, if a bug comes up that really would require you to do a massive refactoring, you're just not going to do it. And your program is going to start just look ugly, and you're going to hack it.
I also, another thing I don't miss is what I call stuttering, where the C style of declarations match to object-oriented programming style, which you see in Java and C++. You get a lot of, you know, string equals new string kind of thing, except string is much longer than string. And in Go, the declaration style, this is one of the reasons we went with Pascal style, is it gives you a chance to elide a lot of the noise in the declarations and simply derive the type from the expression. And that saves a remarkable amount of typing and a remarkable amount of typing.
I really appreciate not having optional arguments to functions, so that functions always have a specific set of arguments, and that's what it takes. I find in terms of readability, that's awesome. By the same token, like things like list comprehensions or even ternary operators, these are things that make code more convenient to write, but they make it much more difficult to read. And yeah, when I first sort of started using Go, I sort of found myself feeling, oh, I have to write this for loop again, and so But now the benefits have manifested really strongly in interoperating with other people's code.
I think somebody else already mentioned this too, but it's really empowering to be able to put all your code in one file and not being enforced to, have header files or have, one file per class or whatever your import name is, have a file. It's just like you can hack something up and then structure it later so it's readable for other people, but you don't have to context switch while you're writing code, jumping around files.
There was a question earlier about the design process, and another thing that we really struggled with, but you can't tell now looking at the language, is what a package was. There were endless debates about the structure of a package and how it went together, and it looked like it's just sort of obvious, but it was a really difficult thing to figure that out. And maybe we were just stupid, or maybe we were burned by using the wrong languages for too long. But I think that is something that worked out really, really well.
What's the feedback been from novice programmers? A lot of people using Go, and everyone probably in this room is very experienced in programming. But what about people new to programming when they look at Go programs? What's their feedback been?
So I've taught a bunch of classes at universities in Go, and I found that most people who have like a sort of very beginner level knowledge of programming in languages like C or Java pick it up pretty quickly. The main stumbling block that people who come from non-C backgrounds have is with pointers. But I think that's just a natural reaction when you've been using a language like Java, which has pointers but just hides them behind the concept of references. It's very strange to just deal with them explicitly. But then people who came from C, who were beginners, I actually had a few come up to me afterwards and say, wow, I actually understand pointers now after using Go. It's so much easier than doing it in C. Even though semantically they're pretty much the same. But yeah, I actually think that Go is a fantastic teaching language, and I would love it if universities and other training academies would take it on as a teaching language. I think it's really well suited to that.
In the early design of Go, was there much consideration in incorporating a sort of more functional language influence? Something maybe very fundamental like a polymorphic type system, or something a little bit easier like having the API incorporate lambdas more?
We had to talk Ken into what's there. Early on, the closures weren't true closures. They were just function literals, and you had to pass in all the parameters. It took a while to convince ourselves that we could actually do them efficiently inside a compiled language. And there's a fair bit of work. There's even a little bit of runtime code generation when you run a Lambda inside Go. It's not our background, functional languages exactly. I mean, I've written a lot of Lisp in my time, but and I really think they're important. A really important part of concurrent programming is the ability to launch into little tiny computations. So it's really important that we have the power. But the short answer to your question is no. We didn't want to push harder in that direction. Although now looking back on it, I kind of think we had. But I do think that what's there is pretty expressive because you do get true lambdas and all that.
Yeah, I think that's pretty much summarizing it. I think having the true closures is a major boon for the language, and it wasn't there in the beginning. I actually wanted them from day one, but we have them now, so I'm really happy about that.
I really enjoy programming with Go routines and channels. But I've also been reading about data structures that can be accessed safely from multiple threads in other languages. Is there any interest in adding data structures to the standard library or to the language that can be used safely from different Go routines?
Well, there is a library, the sync library, that lets you do the protection yourself. I think the question you're really asking is whether there's a notion of immutability on the horizon for stuff. Or are you asking, is that what you're getting at?
Well, that's one side of it, and there's also there's lock-free data structures that people are playing with in Java and C++ that might be interesting, like map data structures and list data structures that could be used safely, so we don't have to synchronize explicitly across channels.
Dmitry Vyukov, who was mentioned before, is doing the garbage collector and scheduler work, is probably as good at lock-free stuff as anybody you might know. And I suspect in time he will start putting that stuff in. He's actually mooted a few things like that already. So I think there will be some of those coming in. Yeah.
I want to add that there's also, of course, the lessons learned from Java, perhaps, where the data structures, or many data structures, were built from day one so that they could be used concurrently. And so they all do locking. And it's an incredibly expensive proposition in many ways. And it's not clear that it's the right way to approach things.
Well, that was definitely a mistake in Java, it seems, for performance. But
Thanks. All right, well, we've done a full hour of questions, which is great. Thank you, everybody, for coming along. And thanks, Go guys, for answering all the questions.